Okay, so the next session is Haskell, Leisure Code to the next level. Please welcome Tsuyoshi.
Okay, so I'm Tsuyoshi Chujo. I'm a freelancer in Japan, and I'll talk about Haskell. So before talking about Haskell, do you know this expression, UI equals f of state? Who knows this one? Half, maybe? Okay, thank you. So this is the basic concept of the UI building in Flutter. So UI stands for the layout of the screen, which user will see on their devices. And F is our build method, and state is a value which is we can retrieve from the state management packages or stateful widget or inherited widget. So, in Flutter, every UI is built with the result of the build method. And the Flutter document also is saying start thinking declaratively. So what is declarative? So before describing the declarative programming, we have imperative programming, which is focusing on how with the step-by-step control flow. I will show you the sample code in the next slide to express the imperative coding. So, and declarative coding focuses on what? So the important thing is returning the value as soon as possible. So that is declarative. So here I prepared the imperative code. It's a pseudocode to demonstrate the imperative coding, so it's not the actual one, but in imperative coding, the step-by-step control flow is the important. How to achieve the returning value is the important. So we retrieve the data first and check something next and build the parent widget, child widget, build everything, and then return the parent. Return the UI. So the imperative coding, the returning value comes to the end of the function or method. But it's not descriptive, or it's not easy to understand what is going on in the imperative coding, or what will be returned by the method. So, this at the bottom line, maybe you cannot even see this line from the back of this room, right? So, but in contrast, declarative coding is very concise and clear. It is doing the similar thing, but it clearly describes what will be returned from build method, because it only preserves the single statement of switch and returning the widget based on the value. So this is very concise and easy to understand what will be returned from the build method. This is declarative. And what is so build method also should be pure, because the build method is called by Flutter framework, and we cannot expect when and how much it is called. So it all depends on the Flutter framework's requirement. So it should be pure. Otherwise, pure means the functions or methods cannot introduce observable side effects, like mutating the state, or calling API, or saving data, or communicating with other systems. It's not pure. So make the build method. To make the build method pure, you cannot introduce that kind of any observable side effects. So you can imagine that if we call setState during the build method, the Flutter framework will cause the error, right? So that means the build method has to be pure. And pure method also returns the same output on the same input. So as long as the state is the same, the output UI should be the same. That is pure. So have you seen this build method? Who have seen this one? I believe all of you, right? So, yeah, I saw this one in this morning. So this is not pure because the some service.register handler causes the side effect. This means handler, so this function will register the handler object to the outside of the build method. So that is impure. So why declarative, why pure? Oh, sorry. So pure and declarative code, which is function, the declarative and pure function or method is so descriptive. It just consists of the single expression and returning a value at the top of the method. So it's very easy to understand what it returns. And it's also predictable because there is no side effects. So even if the function or method is called multiple times, there is nothing happened. It just receives the input and just returning the output. That's it. So it's predictable. And it's also testable because the input and output is so clear. So we can just pick up one function or one method and give the arguments as an input, and we can test output. So the benefit of the declarative and pure function is like this. But we have one issue that Dart is not strictly support or enforce the declarative and pure coding because Dart is a multi-paradigm language, so we can write imperative code, we can write impure code, and we can both declarative code and we can both pure code. So the important thing is that we have to achieve the agreement among our project members by making some guidelines or rules to keep our build method declarative and pure. So how can we do that? How to make that kind of guidelines or rules? So we have Haskell here. So what is Haskell and why Haskell? So Haskell is a functional programming language which is strictly declarative and strictly pure. We cannot introduce any imperative code inside Haskell, and we cannot direct side effect. We cannot introduce direct side effect into the Haskell functions. It must be pure. But still, the Haskell enables us to build any kinds of software like backend app or GUI app or even game app can be built by Haskell. So I believe the Haskell will provide a lot of ideas to make our Flutter code declarative and pure, which means functional. So before starting the discussion, let me introduce some Haskell coding to make sure we are on the same page. By the way, who have built the Haskell software before? No. Okay. Oh. Yeah, I know. So it's important to make sure how Haskell code looks like. So we have two functions here, add function and increment function. Then the basic structure of the function consists of two lines. The first line is the definition of the function. The add is the name of the function, and int stands for the input and output. So we receive this add function receives two values as an argument, two int values as an argument, and it returns one int value as a result. So the second line is the function body. It also, we also write the function name again. Then the x and y is the arguments of the add method, which is int value. Then it returns the calculation of x plus y. So that is the very basics of the Haskell function. We have also increment function below that. Also we have definition of the increment function here. It receives one int value and returns one int value. then the next line is the body. It receives an argument named n and returns the result of calling the previously described add function. So the function call of the Haskell looks like this: function name and argument, first argument and second argument. So that is the very basics of the Haskell code. But don't worry, it's not very important to understand how we implement Haskell code. The point is to borrow the idea of Haskell into the Flutter code. So the implementation itself is not very important. So let's start mimicking Haskell. But to express the sample code, I just prepared the sample app, which is the widget tree editor. We can generate random widget tree here, and we can add some more. Then select one, and we can also edit the widget tree like this. It's a tool for making the figure of the widget tree. So that's it. It's very tiny. So using this sample app, let's go ahead to the discussion. So we have two panes of the that previously explained sample app. We have this here and the editor here. So our build method of this app looks like this. So this build method returns raw widget, and it consists of the tree means the widget tree. So the list view and editor view. So the point is using the arrow syntax in every build method. Arrow syntax is this one. So this always enforces us to keep the method or function in single expression. So the first rule to keep our build method declarative is to use the arrow syntax always. But sometimes, no, usually we want to prepare for the value before returning the widget. Like we may want to call the ref.watch or media query.context before returning the widget. So how can we do that in a single expression? So in Haskell, we have let, this one. So the idea of let is to clearly separate the value preparation and function body. So we have the increment function again here. And before the function body, we have additional one line. This one, let step equals 1, which is doing to the preparing for the value named step, and bind the value 1 to that step. Then we can, at Haskell, we operate the next line at end step. So it enables us to clearly separate the definition and operation. And it's still declarative because the body is still the single expression. So let's mimic it into the Flutter code. We have list view here again. And to build this list view, we have to retrieve the data from the inherited widget, which is named tree list app state, this one. So how can we do that? Because in Flutter, everything is a widget. So the let feature is also can be implemented as a widget. So we just implemented this one, let widget. The implementation is like this. This is very simple stateless widget, which receives the record here, record and builder function as an argument, and then just call the builder function as soon as its build method is called. So it's very simple, but thanks to this let widget, we can write our build method like this. So we can still use the arrow syntax, which means the expression is still the single. And before returning list view, we wrap the list view with let widget. Then provide a record which preserves the state, which is the value which we want to use to build the list view. Then we provide builder function to build the list view. Sorry. This one. So the let widget enables us to keep the build method declarative, even if we have to prepare for the value before building the list view. So this is one proposal. By the way, I'm talking about this discussion as an extreme opinion because it's not the best practice kind of things. I never say we have to write like this, or I don't say this is the best way to write this build method. It's a kind of extreme opinion, but it's very nice. I believe this is very nice to start discussion to make our Flutter code better. So depending on our issues, maybe all the projects have their own issues, right? So this opinion can be the first step of the solution. So I just continue the discussion. So next one is branching. So if the user is have free account or guest user, we may want to show the pricing page. And if the user is already paid account, they have already paid account, we may want to show the account page. So how can we do that in that case? So Haskell have pattern matching. So the idea of pattern matching in Haskell is like this. We have the increment function again. But now we have two line of bodies here. And that is pattern matching in Haskell. So if the input, the argument is exact 100, the Haskell will call this line. And otherwise, Haskell will call this line. So this is pattern matching. So we can write several lines of bodies based on the input. So it's very simple in Dart too. Because we have pattern matching, that's the functionality of with the same name, pattern matching. And we can use pattern matching with switch expression here. So we can combine the declarative programming with and switch expression smoothly. So we have the list view here again, and I also prepared the reload button here. If I press this one, it goes the loading state and empty state, and we can again generate another data. And now the state is the data state, which is this one. So by using the switch expression, we can clearly describe the build method potentially returns three kind of widget, like loading state, empty state, and selecting tree list state, which returns list view. So that is the idea to import the idea of pattern matching into Flutter's build method. So far, using arrow syntax, using let widget, using pattern matching makes our build method fully declarative. Congratulations. But wait a minute. What about business logic? Actually we have made the functional build method, but the source code we write in the flat app is not only build method, but also we have business logics or some other functionalities. So how can we make those logics functional? So we have the widget tree editor again. Oh, sorry. We have to select in this page. Okay. So we have the functionality to edit the widget tree like using drag and drop like this. And when I dropped the new node to the new widget to the existing widget tree, the business logic will calculate the updated widget tree, the data structure of the widget tree, and generate the new structure of widget tree. So this is business logic, but it's not it's not called side effects because it just receives the input. It just receives all the information as an input and just returns the new widget tree as an output. So in that case, it's very easy. It's the same story as build method. So this is a simple and static function. Actually, it's a method, but yeah, we can consider it's a function. This insert below method just receives everything as an input, as an argument, and then we can declaratively build an updated widget tree and return the new data with a single expression. That is the same story as build method. But business logic tends to, we usually want to create side effects when on business logics. Like if we want to save the data to the database, we have to do the storage.add and give the data to the storage, and we may want to introduce the side effect. Or we have to retrieve the data from the API, or we want to save the log into the local data or something like that. So a lot of business logics have to cause side effects. So how can we do that? How can we manage that? So Haskell have monad in that case. To describe the monad in detail, I have to have 2 or more days or more. So it's very complicated. So I have a lot of things to explain to understand monad. So I just briefly explain how monad works. So monad is a type which preserves a value. We have 100 int value 100 here, which preserves a value under a certain context. That is monad in general. But it's very general and difficult to understand. So let's take a look at some examples of the monad. So we have maybe monad here. Maybe monad preserves a value, but it potentially be nothing, which is null in Dart. So in Haskell, the Haskell doesn't have the value of null as a language feature. So Haskell introduces the maybe monad, and it can preserve 100 or nothing. It's meaning nullable. So either monad shares the same idea, but it preserves an error. It preserves value or error. So if we want to operate do the sum operation, which potentially cause the error, the return value should be either, which means which can preserve the value as an output or error. So another example is IO monad. This also preserves a value. This also provides a value, but this causes the IO under the hood, that is IO monad. So like if we want to fetch the data from the API, we use IO monad in Haskell. So let's borrow the idea of monad, especially IO monad, to save the data to the storage. So save method again here. We have save method. This is the original one. To make the save method declarative and pure, I just introduced effect object, which is it's a simple object that preserves function which causes side effects like this one. And yeah, it's just an object which preserves the operation causing I/O. And then save method, what save method do is just returning the effect object as an output. So now the save method is now pure and declarative with the single expression of making the effect object. But what is the benefit of this one? Why do I do like this? To explain that things, before explaining, we have one example that shared the idea of monad in Dart, which is future. Who knows future? Yeah, everyone must know future. Yeah, the future is the object that preserves an operation which have to await the response from the outside systems. Like if we want to communicate with the database, or if we want to communicate with the backend server, the future comes to our Flutter code. But the future is just that object which preserves that kind of operation. And we usually use async keyword instead of future, but it's just an syntax sugar of wrapping the operation with future, so it's the same story. So the benefit of future is that we can call the method returning the future object, but we don't need to immediately await the result. Before awaiting, we can configure the timeout, or we can chain another operation with .them method, or we can register the handler by calling catch error method. That is the benefit of future. And then everything is set up. We can just await the future and retrieve the data from the future. So that is the idea to introduce the IO monad in Dart. So we can do some kind of, we can introduce this kind of tricks into effect object, but I don't implement it yet. But it's okay, I'm just introducing the idea. So by wrapping the business logic with a certain object, the business logic is going to be declarative and pure, which means that testable. And it's also declaratable, which means we can insert the mocking system, or we can insert some logging operation before the future operation or something like that, or we can chain another operation before calling that kind of impure operation. So that is the benefit of introducing the idea of IO monad into Dart. So this idea is explained in the word of functional core and impure shell, which is the structure of the software architecture that clearly separates the functional core layer and impure shell layer, which the functional core layer, all the functions inside the functional core layer produces functions which is declarative and pure functions. And then the impure shell will operate handle all the values retrieved from the functional core. So our business logics or build method are inside functional core. It's very important. It has to be testable. It has to be clearly understandable. So that is the functional core. And we still have the layer to manage everything retrieved from the functional core. So in practice, the Flutter framework is a impure shell. Because when we dive into the Flutter framework source code, like framework.dart, which is the source code, the core source code of the Flutter framework, we have a lot of impure and we have a lot of imperative code implementation inside that. So thanks to the Flutter framework, we can focus on our build method, making it declarative and pure. So that is the clear separation of a functional core and impure shell. So, and I almost discussed everything, but I have a lot more features. We have a lot more features of Haskell that we can improve our Flutter programming. Like the type system of the Haskell is very expressive, it's very strong. The monad is also the usage of the type system. The monad is not the language feature, it's just using the type system. So it's very expressive and it's extensive. And as long as we leverage the types, the compiler can easily infer or analyze our program is doing correctly or not. So because compiler cannot understand the operation, but compiler can understand the type, right? So it is the same story as Haskell and Dart. So using the type system and importing the usage or approaches or techniques using type system from Haskell, that code program can be better. And laziness. All the expressions in Haskell are evaluated lazily. So in Haskell, you don't need to understand this one, but it generates the infinite number of the list. In Haskell, we can generate infinite size of the list. It's relevant in Haskell because the Haskell doesn't immediately generate the infinite size of the list. So it's up to users. So if sorry for its very bottom side, if we want to take 5 elements from that infinite list, Haskell will generates just 5 sides of the list. So it's lazy. So we can do the same thing as using the iterable class in Dart. Do you know iterable class? It's not the object that we have to put to list. So it's the list, the data structure that is evaluated lazily. That is the iterable class. So we can, if you are interested in lazy operation, you can check the iterable class and sync, maybe sync asterisk kind of keyword attaching to the method. And also we have several Flutter and Dart packages which enables us to achieve functional programming, which is fp-dart. This produces a lot of types that is useful in Haskell. And we can do the same thing in Flutter or Dart programming using this fp-dart. And also we have rearg package. This is the state management package, which is inspired by functional programming. So every state is preserved or managed with the function. So it's interesting. Actually, I have no experience to use this package in the production code, but it's valuable to read the document and get the idea of how it works. And also, Jungle, already discussed about this topic, the joy of functional programming in the Flutter.com. So you can also check his discussion, his presentation. You can visit the YouTube channel, and yeah, you can see that one. So I strongly recommend to watch his presentation. So my message so far is enjoy programming and don't hesitate to visit another programming language, another frameworks. They will inspire us to make our Flutter codes more readable or testable, enhance our Flutter code. So yeah, thank you for listening. And if you are interested in me, feel free to visit my portfolio page from the QR code here. You can find my articles and packages published. And you can also find the social accounts in this page. So yeah, thank you.
Thank you so much. So move on to the Q&A session. So if you have any questions, please raise your hand. Chujo?
Thank you so much for the very insightful presentation. I might know the answers, but can you tell us how did you achieve these amazing slides with the built-in Flutter code?
Flutter deck. Yeah. Do you know Flutter deck? This is the it's a Flutter package that enables us to build the slide deck with Flutter.
Wow, it was very cool. Thank you so much.
I also recommend to use animated package to animate any kind of widget, which is my package. Fireworks was not using the animated to package, maybe this one. I just implemented with animation control, a lot of animation controllers, but I like this one, but it's laggy. Okay.
Any more questions? Good. Okay, thank you, Tsuyoshi. So please give applause to him.
Thank you.